Alright, so today we're going to work on some problem solving strategies. We're going to use a strategy called guess, check, and revise. Okay? And then after we're done with that, we're going to do some least common multiples. Both of them pretty fun, I think. The guess, check, and revise is this is one of my favorite things to do. Because, for math? No. Because it's problem solving. And it takes a little bit of thought to say, okay, how am I going to set this up? How am I going to do this? And I enjoy that. So, excuse me. On your whiteboards, before we get started, we're going to do a little warm up. We're going to write each fraction in simplest form. So what's the first thing we need to figure out before we start?
If it's simple, simplified.
If it's already been simplified. So if it can be simplified. Now, once we know that it can be simplified, we need to know what?
How many times it goes into it?
Or the term for it. We're looking for the what? Between the numerator and the denominator. Let's go. On your whiteboards. Okay. So thanks to our friends that came up and did this up on the board. We now know that number 1, 15/45 can reduce. We did it twice, which is fine. We divided it by 5/5, which gave us 3/9. 3 and 9 still have a common factor, which is 3, which gives us 1/3. Over here, 12/30, or 12/30ths. We divide that by 6/6. 12 divided by 6 is 2. 30 divided by 6 is 5. We have 2/5.
Awesome.
Number 3, 7/26, it's already simplified. 7 is a prime number, which means the only factors are 1 and 7. 7 cannot go into 26, so we're done. Number 4, 28 and 42. Our friend divided the top and bottom by 7. So 28 divided by 7 is 4. 42 divided by 7 is 6, which gives us 4/6. Unfortunately, he didn't realize that 4 and 6 are both still even numbers, which means by definition an even number is divisible by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So we're now done. Alright. So today what we're going to do is we're going to work on a strategy called guess and check and revise. So we're going to look at word problems. I think this is fun. Some of you will agree with me, and others of you are going to think that I'm nuts. But that's okay. We're going to talk about a Bactrian camel, which has 2 humps, and a dromedary camel, which has 1 hump. And I wish we were doing this on Wednesday. Alright. So, Toby went out and he saw a bunch of camels. Toby likes to count. He's probably little like one of my kids. One of my little ones. Probably like my 7-year-old. My 7-year-old wants to show everybody how smart she is, so she wants to count everything and read everything. Okay? So, go out, bunch of camels standing. Count all the camels, there's 20 camels. Then he wanted to one-up himself. I know that there's 20 camels. Then he counted all the camels' humps. Got 28 humps. Now, based on what he counted, 20 camels and 28 humps, I want to know how many of each type of camel there are. Okay? There are 2 types. So, we're going to take the facts that we know out of the question first. This is why I like it. It's kind of like an investigate. You get to investigate the question. It's not just, 5 times 2 is 10. You actually have to go through and pull some stuff out, and it takes a little bit of common sense to figure out how to set the problem up and how to solve it. Okay? So, the facts. What do we know? We know that Bactrian camels have 2 humps and dromedary camels have 1 hump. We know that there are how many camels?
2.
How many? There are 20 camels. With how many humps do they have?
28.
28. Then it says, what do we need to find? What do we need to find? How many what?
How many times? How many kinds of humps? How many types? Camels. How many camels?
How many camels of each type there are? Okay, so we're looking for how many camels of each type there are. Now we're going to guess, check, and revise to solve this problem. Okay, guess. It means we're going to come up with what we think is
the answer.
So let's take a look. So what they did here is they created a chart. Here's our two types of camels. This is how we're going to find out the number of humps. And then we're going to find out if the number of humps is right. Okay? They just picked two numbers that equal 20. Look at 7 and 13. 7 plus 13 equals 20. So then they go, the Bactrian camel has 2 humps. So it's 7 times 2. This camel, the dromedary camel, has 1 hump. So it's 13 times 1. 7 times 2 is
14.
14. Plus 13 times 1 is
13.
So 14 plus 13 is 27. Now look, because this has 1 and this is 2, we're short, right?
We're short 1.
So we're going to take the number with the least amount of humps, and we're going to take it down 1 to 12. We're going to increase the number of 2 humps to 8. We're going to check it again. 8 times 2 is
16.
12 times 1 is
12.
16 plus 12 is 28.
That's correct.
That is correct. So we now know that there are how many Bactrian camels?
8.
8. And how many dromedary camels?
20. 12. 12.
Now, the two things we need, 20 camels. 8 plus 12 is?
8 plus 12. 8 plus 20.
8 plus 12 is 20. And then 8 times 2 was?
16.
12 times 1 is?
12.
16 plus 12 is?
28.
So, here's how we check. See? We're checking. 8 plus 12. 20 camels. 8 times 2 is 16. 12 times 1, which is 12. That equals 28. Does it?
Yes.
So we checked it. Our answer is right. So you kind of get to, it's investigative math. Somebody gives you a word problem, you figure out how does this work. Some of the questions will have more than one answer. Okay? So far so good?
I guess. I don't get it.
So here we go. Now we're going to do one on our own, or together I should say. We have a young man that likes to collect baseball cards. Or hockey cards, it doesn't really say, football cards. Anybody collect cards in here?
I do. Yeah. Oh, I do.
Fantastic. So, this kid's name is Connor. Connor spent $66 on rookie cards and Hall of Famer cards. How many of each type of card did he buy? So, what facts do you know? What facts do we know out of it?
He spent $66
Okay,
on cards.
so we know that he spent $66 on cards. Do we know anything else? We know that he bought rookie cards and Hall of Famer cards. Do we know anything else? Williamson.
His name is Connor.
Does not have anything to do with my math problem. But you are 100% correct. His name is Connor. So I get that is a fact. We're looking for math facts, so things that we need to solve our problems. What else do we know? What did they tell? Yes. So 4 of these are $6. And what?
The Hall of Fame card. 2 of them are $18. $9.
2 for 19. 2 for 9, sorry. Okay. So this is what we need to know. How many of each type of card did he buy? So what do we need to find?
How many cards? How many of each type of card did he buy?
Did he buy? That's what we want to know. How many of each type of card did he buy? So we're going to start figuring this out. Okay, so here's our plan. What's my plan? Nobody? Yes.
You divide?
Divide?
Oh, wait,
No, I don't want to divide. Yes, sir.
Multiply 4 for 6 and 2 for 9.
4 for 6 and 2 for 9.
For the rookie Hall of Fame card.
Not yet.
You multiply 66.
See that? 7 times 2 plus 13 times 1. 8 times 2 plus 12 times 1. And our total. So what we're going to look for, what total do we know? We know the total of something. What do we know the total of?
How many dollars he spent?
Which is what?
$66.
Now we know something else. What else do we know? Yes.
You have to times the number to equal to 66.
We're going to have to multiply something, but what else do we know? How many different things did he buy?
2.
2. So that means we're going to have to add the 2 things together. Right? Now I'm going to put parentheses up here because those are also going to be, okay? What's the first thing that we know? What's the first thing? What's one of the things he bought? Yes.
Rookie cards.
How many?
4 for $6.
How many?
4.
How many? Do you know? So we don't know how many he bought, but we know that whatever that number is, we have to multiply it by what?
6.
6. What else do we know? Rudy?
Okay, so we know that on the Hall of Famers he paid $9.
We know that he paid he also bought, so he bought rookies and he bought Hall of Famers, and we know that the Hall of Famers
Cost $9.
cost $9. How many did he buy?
We don't know. We don't know. And
So we have an unknown number times 6 plus an unknown number times 9, which equals 66. Now this is where things get a little interesting, because our question, normally it would say he bought rookie and Hall of Famer cards for $66 and he ended up with a certain number of cards. So our 2 question marks would equal something. our question mark plus our question mark would equal a number.
6.
They did not give us a number, which means this is going to have more than one answer. Okay?
Just went back to the.
What's on the plan? What the?
I messed up. I put 2 plain things in there. Alright, so now we're going to solve it.
Oh, yeah.
So, we're going to solve our question mark times 6 plus our question mark times 9. And that's going to equal 66. Put all our dollar signs in. Now, somebody give me 2 numbers. Give me a number that you think is going to make 66 for these 2. So, how many rookie cards are we going to say that you bought, Ricky?
6.
We're going to say you bought 6 rookie cards. 6 times 6
36.
plus, how many Hall of Famer cards are we going to say that you bought? Yes.
4.
4. Does that equal that?
No. Nope.
No. This equals 72, right? Can somebody tell me what the answer is now? Yes.
I think it would be 5 times 6 and 4 times 9.
There you go. 5 times 6 plus 4 times 9
$66.
equals
66.
66. So 5 times 6 is 30 plus 4 times 9, which is 36, which would equal 66. So you guys figured it out. Now, this is why there's more than one answer. I could have said there was 11 rookie. He bought 11 sets of rookie cards. Okay.
And 0.
And no Hall of Famers. Now, it wants to know how many type of each card, though. So it doesn't. Is this how many of each he bought?
Yep.
Is it?
No.
Yep. No. I know why.
Gibby, how many rookie cards did he buy? Our answer, the one that we came up with.
I
Does everybody agree with Gibby that he bought 4 rookie cards?
No.
No?
know.
Roskowski, how many rookie cards did he buy? Nope.
I know. 30.
How many? Nope.
11.
30.
Nobody's figured this out?
11.
He bought how many packages? How many cards? 5?
20. 20. 20.
Oh yeah, 20.
20.
20.
He bought 5 packs. So the rookie cards. He bought 20 cards because he bought 5 packs of 4. Hall of Famer.
6.
How many packs of Hall of Famer cards did he buy?
6. 8. 2.
How many packs did he buy?
8.
4.
8.
So how many did he buy?
8.
8. Now, this is what the second part of the problem should have said. He bought 28 cards. They didn't tell us that, but Oh well.
Oh, I got time.
So most of these problems are going to have two different ways. You're going to be working in two different directions. Okay. Is my answer reasonable? Well, we already checked it.
The answer is 200.
So we said he bought 5 of his rookie cards for $6, or 5 sets of rookie cards, and then he bought 4 sets of the Hall of Famer cards for $9. And that equals the $66 that he spent. Well, 5 times 6 is 30, so 30 plus 36 does equal 66. So is it reasonable? Yes, it's reasonable. Okay. Now, then we would also have to do 5 times 4 plus 4 times 2, and then this would equal the total for the cards, the total number of cards, but they didn't tell us the total number of cards. Okay?
It equals 28.
It does equal 28. Okay. All right. Now you're going to apply this strategy. So bike path A is 4 miles long. Bike path B is 7 miles long. If April biked a total of 37 miles, how many times did she bike each path? So this is where we're going to start planning. We know that this is 4 miles. We know that this is 7 miles. And we know that it has to equal
37 miles.
37 miles. What we don't know is how many times she rode here and how many times she rode there. So I set up your first problem for you. They are all going to be like this. Okay? After you do number 1, you only have to do the even problems on the practice. I gave you this for number 1. Let's see if we can solve this real quick. We're looking for 37 total miles, correct? Okay. Now, what's 7 plus 4?
7 plus 4, 11.
11. So we know that it's going to be more than one time on each one, right?
Yeah.
Okay. But now, we know that we're not going to be over 10 because 10 times 4 is going to be 40 and 10 times 7 is 70. So we're going to have a small number. So somebody give me 2 numbers that we want to try here. Give me. 4 for the first one. Okay. 4 times 4 plus what times 7, give me? Two. All right. It doesn't matter. We just want to know if it equals 37. Okay? 4 times 4 is 16. Plus 7 times 4 is 7 times 2. Sorry, 2 times 7. 14. What's 16 plus 14?
30.
Is that equal to that?
No.
Do we know what the difference is? What's the difference between 37 and 30?
37 is more. 7 more.
7 more. Can we make 7 more here?
Yeah,
Yes.
7 times 3.
I figured it out.
7 times 3. So we're going to go 4 times 4 plus 7 times 3. And this should equal our 37. Okay? So 4 times 4 is?
16
Plus 7 times 3 is?
21.
16 plus 21 is?
37.
So, she rode the 4-mile course 4 times.
Okay.
The 7-mile course 3 times. There we go. So this is A and B. You guys are going to work on the even problems on pages 571 and 572. But 4 times nothing equals 30. That's why you have to solve it like this, because you can't just say, okay, 7. They gave you a number that you can't make with a single. Okay. All right. Get started. You can work quietly for the next few minutes. We do have another lesson that we're going to do today. So get as much of this done so you don't get overloaded with classwork.
May I use the restroom real quick?